I think I should be audible now. I did not realize like my mic was on mute. Yeah, like what I was saying was like I felt like probably like I was able to solve all the problem except the last. So I am going to discuss all of these problems. C was mostly proved by like I just made a blind guess there that worked and then I just moved on. So like probably I will say like what my reasoning were for the blind guess, but yeah, like I think I can slightly prove it now. But at least when I submitted, I did not have a proof for it. No, like I was able to solve like this is the system testing, so all the submissions are going out. So one second, like where is my language? So like all the problems are in system testing. So yeah, like probably I think I will wait for a minute and then we will get started. Okay, like I am audible, right? I think I am audible and like probably I don't understand what do you mean by resound by the way. Like is the sound not audible? Is the audio not good or like what exactly is the case? Like is audio breaking or what's the case? Yes, probably won't answer like bad audio, good audio, or something like that would be more helpful. Okay, it's good. Thanks, Rishabh. Okay, so I think I will start from A and I will go in order. A, B, C, D1, D2, E1, E2 would be my order, and I will skip F. So yeah, thanks everyone. Like, so problem A says turtle thinks a string S is a good string if there exists a sequence of string T1 to Tk such that pair K is greater than equal to 2. S is broken down into Tk, like sum of Tk pieces, where plus represents the concatenation operation. For example, A plus ABC is equal to A plus B. For or I to J, first character of I is not equal to last character of J, and like that's the only thing which is required here. Turtle is given a string S consists of lowercase Latin letters. Please tell him whether a string S is good or not. So probably let's try to boil it down into different cases, like what's happening here. Mhm. Okay, I think we are starting now. So one thing we have to do is like let's say this is the given string to us. We have to split it down into multiple different parts first, so that all the characters are taken and no character overlaps there. Like for example, one way to split it can be this. This as the first string. This as a second string. And this as a third string. Let's say this is how we have split it. This ensures that k is greater than equal to 2. If you concatenate, like append one string after the other, you will get the original string. And it also wants like for all the characters I and j, first character of the first string before it should not be equal to the last character of the string last it. So in this case, like this should not be, if we look at these two strings, first character of this string and last character of this string should not be equal. S1 should not be equal to S7. Then first character of this string and last character of this string should not be equal. Then first character of this string should not be equal to last character of this string. And I think these are the only conditions when we divide into three strings. If we have more strings, we can have more such conditions. You can see now, see, like this is one of the critical condition we have. because does not matter how you start, there would be some starting part which will have some first string, and no matter how we divide, there would be some ending part which will have this string, like this character. There will exist one string where S1 is the first character, and there will exist one string where S9 is the last character. So this should always hold true. And essentially, this is the only if condition we need over here. Like first character should not be equal to last character. And like this is the first condition we need. And now notice one thing. Instead of taking 3 characters, we can always get the work done with 2 characters. Let's say if we take this as a first string and this as a last string, then the only condition we need is S1 not equal to S9. And do we need more? Like 1 second. And essentially, like this was the only required condition we need over here. Like if S1 is equal to S9, basically first and last character are equal, then no matter how you divide, one of the string will have S1 as the first character, and one of the string will have S9 as the last character. And like for these two strings, like the first character of this string and last character of this string will always be equal. And if so, print no. Otherwise, if S1 is not equal to S9, then my idea was like just split it into 2 strings like this. Let's say this is one part of the string and this is other part of the string. Doesn't matter what the midpoint is. S1, S9. First character of this string is not equal to last character because we have this condition. Essentially, this was the only solution we did. So like 1 second, this is B. So like if first and last character are equal, print no, otherwise print yes. Any questions on the first problem before I move on to problem B? Okay, let's move to problem B. It says Turtle and Piggy are playing a game too. Turtle and Piggy are playing a game on a sequence. They are given a sequence A1 to AN, and Turtle goes first. Turtle and Piggy alternate turn. So Turtle goes first, Piggy second, Turtle third, and so on. The game goes as follows. Let the current length of sequence be M. If the current length is 1, game ends. If the game does not end and it's Turtle turn, then Turtle can choose any integer and set AI equal to max of this and remove that integer. And if the game does not end and it's Piggy's turn, the Piggy must choose an integer I, set AI equal to minimum of 2 index and remove AI plus 1. Essentially, like let me take some samples here to show around like what type of game people are playing here. Let's first look at some examples to see what's going on here. Let's say this is our array. 3, 4, 5, 6, 10. Let's say 7 is here, 9 is here, 1 is here. So when it's Turtle's turn, Turtle and Piggy, like probably let's call them first player and the second player. Makes our life a bit easier. So if it's first player's turn, what he can choose is like he can choose any integer here keep maximum, like for example, he has chosen this. What he is doing is like he is keeping maximum in those two numbers. Like basically maximum 9 and 5 is 9. So it's equivalent to like basically erasing this 5 from here. And when it's second place turn, what the guy is basically doing is like he looks at two consecutive integers, remove the larger number from there. And this is how the game is playing right now. Or probably, for example, let's say if the first player takes these two turns, he keeps 7 as it is and removes the other number. Or if it's second player's turn and if he is choosing this, he is basically removing the maximum number and keeping the smaller number. And like this is how the game is playing right now. Any questions on like what the players are doing before we try to, and like the first player's goal is to find the maximum possible value of the last number which remains, while second player's goal is to find the minimum possible value the last player remains. Find the value if both players play optimally. Note section is also given. Like for example, in that first test case 1 and 2, first player keeps maximum of these two integers. So only 2 remains, the answer is 2. So the idea here was like, let's first sort all the integers first. Player can choose any integer from like, any index, any two consecutive elements player can choose, and he has to either keep maximum of them or minimum of them. So like, let's see, like the first player who wants to keep the maximum, like it's in best interest, like in the very first turn, he should get away with A1 to begin with. You can probably verify, it does not matter. So what he can do is like, he can choose any number. Like let's call like not sorted. Let's call initial array is A. Like let's probably just write some numbers there. Let's look at this sorted number first. This is a sorted A. 1, 2, 5, 6, 7, 9, 10. What first player will do is like, he will choose 1 and one of the nearby element, any element, it does not matter. For example, this. This way he can get away with 1 from here. Now it's second player's turn. He should look at where the maximum number is and choose it with any of the neighbor here. For example, 10 and 9. So he will get away with 10 from here. Players can keep going it like this. Now it would be first player's turn again. He will choose 2 and one of the neighbor, for example 2 and 7. And now he can get away with 2 from here. Now it's second player's turn again. He can choose where the maximum number is 9. Choose it with one of its neighbor, for example this, and remove the maximum number from here. And you see, if the game keeps going like this, only one number will remain at last, which would be the median here. And the answer is basically median. For example, if you have 7 numbers, B1, B2, like let's call indexing from B0. If you have 5 numbers, then this number goes in the first one, this in the second, this in the third, this in the fourth, this is the median. Or for example, if there are even numbers there, this number goes in the first turn, this number goes in the second turn, this in the third turn, this in the fourth turn, this in the fifth turn, and this remains. And essentially this was the solution for this problem. Like basically find median, print median. And in case there are odd number, there is only one unique median. If there are even numbers, there are two median, and first pair has one extra term, so he will keep the larger median here. Why is this the optimal strategy? Yeah, probably I can try to take another step at it. Like, let's say this is the sorted order. And like the first pair will get 3 turns, 6 numbers. Will remove 3 numbers. And second player will remove 2 numbers. So let's say in case the first player has removed these numbers after doing some operations, then like the second player can remove these numbers, and your optimal median would be even worse than this was the earlier. Yeah, like what I am claiming is like, let's look at the sorted order, and when you want to delete minimum, pick where the minimum is and choose any of the nearby element. And when you want to remove largest number from the sorted order, pick where the largest number is in the original sequence, pick it with the one of the nearby element. Because like if you are removing the shortest element and if it is your first turn, any nearby element you choose, like that number would be larger than the number you have. And when you are playing as a second pair and when you want to delete the larger number, any nearby element you choose would be less than the current element we have. And like essentially that was the reasoning over here. So like first pair is getting 3 turns, so he can remove the smallest 3 numbers. If he ends up doing, and so let's see like whatever the first pair is removing 3 numbers, among whatever remains after removing those 3 numbers, second pair will remove the largest 2 number from the remaining sequence. So if first pair does not choose the first 3 numbers, then second pair can in fact reduce the answer. Similarly, if you look at it from the end, if the second player does not remove the largest 2 numbers, something else, then first player can remove some extra number to get one more number there. Okay, pre-test pass means like earlier you have some set of tests which are passed, and like full solution, like full set of solutions would be run later. Okay, like probably okay, I think there are some questions in the chat, but probably I missed out in the side, but having difficulty understanding the sorting part, fit minimum and any number. My idea is like if we have 6 numbers, first player will remove 3 numbers and second player will remove 2 numbers, right? And at last one number will remain. And let's say my claim is like first player will remove the smallest 3 number, second player will remove the largest 2 number. Whatever remains would be the answer. And first thing to notice was like it's always possible for the first player to remove 3 numbers and second player to remove the largest 2 numbers. And the idea is like let's assume like the first player has removed these 3 numbers. Then now the second player can remove these 2 numbers and the answer you will get is B1, which is worse than we were getting earlier, which was B3. And because first player wants to optimize the maximum possible value, it's always optimal for him to choose the smallest 3 numbers. And similarly, let's see like second player did not remove the largest 2 number. In fact, second player removed these 2 numbers. Then what the first player can do is like he can delete these 3 numbers and he would get this. which is better than what he was getting earlier. So like it's optimal for the second player to always choose the largest number so that first player does not overshoot this value we have. And similar case for the first player. And that is why like probably look at the sorted order. First player remove the largest set of numbers, second player remove the smallest set of number, whatever the number remains in between would be the answer. And now like in case of median, like you can see like if there are 6 numbers, first player remove 3 smallest numbers. So fourth smallest is our answer. Similarly, in case there are 7 numbers, both first player will remove 3 smallest numbers and the other player will remove 3 largest number, and fourth smallest would be the answer. Like dry running example, I would say is a good practice. Like in fact, sometimes I do, like it helps us catching some corner cases sometimes, and probably it helps you understand like what is the best, like if you understood the problem correctly or not. If there are only 3 numbers 1, 2 and 3, turtle will choose one number and other player will choose the third number. So if you say turtle removes 3 and the second player removes 3, the answer becomes 1. But if the, because turtle wants the maximum possible answer, what turtle can also do is like he can remove 1, other player will remove 3 and you would get 2. And like that is the reasoning why. He like first player chooses 2 numbers, keeps maximum of them, and his goal is to get the maximum possible value remaining. Second player chooses 2 numbers, keep minimum of them, and his goal is to get minimum possible value. And that is why like the first player should remove all the smallest numbers in every turn, and the second player should remove all the largest number in every turn. Like brute force, thinking about brute force helps, and like sometimes you can now end up reducing the problem there. So any questions on the second problem before we move on to the third problem? I think for the third problem, I will also look at the editorial ones. Like I can say what my decisions, etc. were, but like probably editorial can help me formalize my thought. I will probably skip this jargon and I will probably say like what my intentions were. Like I will probably not end up proving it completely, but that's fine. Like for my code, like you can look at my screencast. Like I do use Sublime Text there. So like Turtle and Piggy are playing a game on sequence. They are given a sequence A1 to A. Sorry, problem C, right? Turtle gives you string S consists of lowercase Latin letters. Turtle considers a pair of string I to J to be pleasant pair if and only if there exists an integer k such that k is between I and j and both the following condition holds. Sk is not equal to sk plus 1, sk is not equal to si, or sk plus 1 is not equal to sa. Besides, Turtle considers a pair of integers I and j to be good if and only if si equal to sj or I equal to j is a pleasant pair. Turtle wants to reorder the string so that the number of good pairs is maximized. Please help him. Like I will take one of the example to show like what's going on here. Like any suggestions, like which example should I try to explain first? Okay, like last example allows a lot of variable. Like I think turtle is a good example. Like first thing first, like we have to choose a string of length at least 2, and like let's look at any string of length 2 first. Or probably I would say other way around. Like let's probably try to look at what are the bad examples here. This is a good string because like these and these characters are equal. If you choose this as a string, this is also good. This is a bad string. Bad string. Because this is your first character, this is your last character. The only K you can choose is this. And this, in this case, these two characters are equal. And these two characters are also equal. Or probably like probably first we can ignore this condition. Because the number of strings we will get with SI equal to SI equal to SJ is always same. Like number of good pairs due to this condition is always same. The reasoning is like let's say if we look at character A, if it appears 5 times, 5C2 like would be the number of pairs with a starting and ending position as I. Or if character B appears 3 times, then 3C2 which would be 3 pairs, 3 would be the count of pairs with first and last character as C. So we should probably, for now, let's ignore this condition because number of good pairs we will get because due to this condition will always remain same, does not matter how we reorder the string. So let's focus on like the second part here. First thing I noticed was any string which consists of like this. Like let's say this is a string. And let's assume that the first and last character are different here. Because if they are same, the number of pairs always remains equal. Let's try to maximize the number of pairs which looks like this. And the idea here is like we should minimize the number of strings which looks like this. Because if a prefix of equal character and a suffix of equal character exist, you will not be able to do it. Rather, a different way to write this string would be rather if you write this string like this, then you see like this is a good string. While this is not a good string. And that's what gave me an intuition. Like we should probably try to reduce the number of pairs which are same in the equal nearby equal characters. Because if you choose any two characters which have start and end at different character in this part, that would be invalid. But in this case, any length greater than equal to 2 is valid here. because a string like this will have only one valid pair, like two valid pair were equal AA and BB. While a string like this will have three valid pairs. These two starts at the same character. These two start at the same character, and this also is a valid one. And like I saw this, then I just ended up submitting it over there without proving much stuff. And one thing you can in fact prove is, like, if frequency of, like, if count C is the number of times character C appears, then if count of every character is less than n by 2, then I can in fact prove, like, I can in fact show like a valid string where none of the adjacent care will be equal. And the way generally you can do that is, like, first sort all the characters based on the frequency. Let's say A appears one time, B appears two times, C appears five times, D appears six times, E appears four times. Total characters we have is 18 characters. What we can do is, we can first start filling E by leaving one space in between. Like, wait, for highest number of times D appears, right? So we first fill D. Leaving one space in between. Then we start filling E. Like E not, basically first look at the character which appears highest time, then look at the character second highest time. That should be C in fact. You kept filling odd positions, and then you start filling even positions. 4C has been filled now. Now E appears four times, so fill E there. Then fill B. Then fill A. Like, if you start filling it like this, basically look at the character which appears highest number of times. Fill it at one up by leaving one space in between. When you are done with the end, start filling from the first empty position and make jumps of 2 again. This method will ensure that all the characters you have filled, none of the nearby characters have equal position if frequency of everything is less than equal to n by 2. If count of every character is less than equal to n by 2. And if count of any character is greater than n by 2, like, there will always exist like a set of characters which will be near to the largest character. It's more like you choose the other character and try to put them anywhere and you should be good. Just ensure that for, if there exists any character which appears more than n by 2, then optimal character, let's say, would look more like this. Like, look at it more like this. There would be set of A's, like, you can basically try to maximize the pair which are not equal by putting other characters at different places. You cannot ensure that all the characters are like this, but yeah, that is the idea. Yeah, like, there can be another different permutations, like another different ideas for this problem. Like, I'm not really sure. Like, this was a blind guess I made, and this one, so I did not bother thinking much about it. Like, Si equal to Sj, number of pairs due to Si equal to Sj will always remain same. Does not matter how reordering we do. And like, that was the reason why I ended up ignoring them and tried to maximize the other pairs. Okay, a few people are saying like A, B, C, D, E, B, C, D, C, something like that may also work. Like, pretty sure that may work. But like, yeah, that's what I did. So, any questions on problem C first? Before we move on to problem D? Like for proof, you can probably refer the editorial there. Like it's keeping count of how many adjacent pairs are there, and then it's saying like you should subtract this count or something. No, like a formal proof, I believe definitely exists, and it's in the editorial. And what I have said is definitely not a formal proof. Just that what I was thinking of when I was trying to solve this problem. Like whatever I have shown is definitely not a proof. Just that what I guessed, what I submitted, I got an AC, so I moved on. Probably that's a bit. It's a constructive problem. Many different ideas may exist here, but yeah, that's where you are. Like my code editor is Sublime, and this is a Xcali Draw app. No, I did not give ad coder today. Like so. Any questions on C before we move on to problem D? So problem D1. There are two parts to this problem. First version says like let's read the problem first. The two versions are different. Two versions are different problem. In this problem, like let's just ignore it for now. One day, Turtle was playing with n sequence. Let the length of ith sequence be li. Let the length of let the ith sequence be ai1, i2 up to ai li. Basically, you have been given n arrays, n different arrays, and those arrays can have different lengths as well. Piggy gave Turtle a problem to solve when Turtle was playing. The statement was as follows. There was a non-negative integer x at first. The turtle should perform an arbitrary number, possibly 0 times of operations on the integer. In each operation, turtle should choose an integer I and set x equal to max of that number and the original array. Okay, sorry, I forgot to show the code for the problem C. Like I will probably jump onto problem C code after this one. Or probably I can show it right away. So what you can probably do is, I think I will write it again. Yeah, I am jumping onto code for problem C. Not sure why my keyboard is giving me a bit of headache. Let's first create a map which contains how many times each character appears. We can run a for loop, find it. These are all the characters here. Now we can sort all of them in descending order. Based on the frequency. Like let's put it this like this. Now let's create a string of length n. Constant auto and x. Number of times this character appears is this. The type of this character is this. So now put this character f times. If the current index where we want to place is greater than or equal to n, stand idx equal to 1. Because we have started with 0, first we are filling all even index, then we are filling all odd index. And like this way, I would be able to fill all the characters one after the other and print the string P you have at long. The answer is definitely different from what we have. I think I cannot submit it yet. So I will submit it once the code is done. But essentially this was the idea. This is the code for problem C. Probably let's jump on to problem D. I think the problem statement we have already read. The problem statement says you have been given some arrays. Let's say B1, B2, B3, B4. This is the first array. C1, C2, C3 is the second array. D1, D2, D3, D4, D5 is the third array, and there can be more arrays. You start with some element x. And in one operation, you can choose one of the array. Let's say this one. And then replace x with max of array, which includes x, comma C1, C2, C3, and so on. Like you can get an updated x like this. Then probably let's say in the next operation you choose this. Then again you can set x equal to max of this x is the updated x you got from here. Up to D5. The problem asks what is the maximum value of x you can get by doing operations like this. Like let's maybe take a sample as well. In the first sample, the first array is, let's say, 0 and 2. And then in fact it even asks us to find f of x for some values I from 0 to m as well. 2, 3, 3. And third value is 7051. So the idea here is, like let's say we start from 1 first. Initially let's say x equal to 1. If you take this C, you need max of 1, 2, 3, 3. Max is the smallest positive integer, smallest integer greater than equal to 0 that is not present in the sequence. So max of this sequence is 0. So now our x has changed to 0. Let's say we take what is the value of 0 we can learn? F of 0 can be 3, right? Okay. Let's say now we take this. Or no, wait, 1. If we start with 1, yeah, let's take this sequence now. Max of 0, 0, 2 is 1, the smallest positive integer not present in there. So now our updated x equal to 1. Next, the idea is let's again choose the same sequence. After this max, our x has become 1. 1, 0, 2. Here the value we will get is 3. So, and you can notice that we cannot never get the value more than 3. So the f of 1 is defined as 3. Like my x was 0 here, and I chose the first sequence which contains 0 and 2. So including x and the original array, the minimum integer not present is 1. Now my x was 1, I again choose the sequence which contains 0 and 1. Now max of 1, 0 and 2 would be 3. And that's how the answer I got was 3. Like whenever you want to do an operation, you take that array and you also take x and then you try to find the max. So any questions on the problem statement? Now it says give this answer for all I equal to 1 to m. Like find basically the value when you start from I equal to 0, 1, 2, 3 and so on up to m. Okay, now moving further. Let's first find the maximum length of any sequence. Let's say like we have this array. And so on. Like you notice like the first missing number here is 3. And the second missing number here is 7. So if you take max when x is not equal to 3, Max of x comma array would always be 3. And if x equal to 3, max of 3 comma array will be 7 here. Like you notice this pattern here? Like we look at, like, let's say this is our original array 0, 1, 2, 4, 5, 6, 9, 10. Here the smallest two missing elements are 3 and 7. So when you try to take max when x is not equal to 3, 3 would be the smallest missing element. And if your x is 3 and you try to take max with this element, the smallest missing element would be 7. So now you can probably notice, and you see like the length of the sequence is 0, 1, 2, 3, 4, 5, 6, 7. Total length is 7. So like if a sequence has 7 elements, and you can see it's also possible to obtain 2 missing elements. So you can never get max greater than equal to 10 in this case. Because in the worst case, those 7 elements would be 0 to 6. First smallest element would be 7, second smallest element would be 8. You would in fact never get 9. So 10, you can never get 10 with any type of operation. And like this was, probably I will come back to this observation later. But let's look at the initial problem as a graph with m nodes. 0 to m is there. From any node, you can go to 3 by using this array, except 3 of course. So on until 3. And from 3 you can also go to 7. So like I first try to create a graph like this. And what we need is, for any connected component, for any node, find maximum reachable node. Looks fine, right? Because if x is not equal to 3, we can reach 3 for any node. Yeah, I am working on D1 right now. Did not went to D. And if x is 3, you can also reach 7. So if you look at this node as a graph where you are, then you can create directed edges from where you can go. Now what you essentially need is, what is the maximum reachable node you can get. And now like the graph will look more like this. Like for example, let's say this is the only array we can get. This is the only array we have. So from any node we can reach 3, and then we can reach 7 as well. But if you see, if we start with 9 or 10, it's never optimal to go back to smaller number. Because if you, from 9 if you go to 3, then you will go to 7. If you do nothing, you will remain at 9. And if you are at 10, like it's not optimal to go to 3 and then 7. If you remain at 10, you would get maximum value. So we can also maintain some value, let's say k, which is maximum of second missing numbers, all the numbers we have got over there. And for any I greater than this k, f of I is I. Basically you do nothing there. Because in any array you look at smallest two missing numbers. If you do an operation first, you can first reach the first smallest number. Then you do an operation second time, you can reach the second smallest missing number. but you can never go to the third smallest missing number. So if you look at among all the arrays you have, what is the maximum possible value of second smallest number you have? That would be the maximum reachable node you can get using the graph we have seen. So any I greater than this, the answer is always I. So we can directly compute sum of this sequence first. First we can directly compute sum of k plus 1 up to m. And then we can try to do a DP to find maximum reachable number in a graph which contains all the numbers from 0 up to k. And this is my solution here. One more observation here was like this is some special kind of graph where like the best you can do is like probably let's say in the first array, like let's now look at focus on smallest and second smallest numbers first. Let's say in B missing element is 3, 7. In C the missing element is 7 and 10. In the third array D, the missing elements are 10 and 14. Then you can see like this is the cycle we have. From any number you can come to 3 first, then you can go to 7, then you can use this array go to 10, use this array go to 14 and so on. So the idea is like you should come back to smaller number only once. Whichever gives us the largest number when you go by this cycle. So let's say like there is another different chain here. 2 which takes you to 5. 5 which takes you to 8. But when you are 8, you can also come back to 3 again and follow this route to get the maximum cycle. So like we should fall back to smaller number only once, and then we will always go to the larger number we want. And so far like this was the critical observation. So what we can do is we can follow this order for j equal to k to 0. For first all outgoing edges to the largest number. Look at all the edges from j to u such that j is less than u, like, and take max of dpu you could get. This denotes the case when you can go, like when you cannot, like basically what is the maximum largest value you can go if you do not go to the smaller value first. Basically for each node what I am trying to find is what is the larger value you can go, assuming that you cannot go to a smaller number. So there would be one cycle like this, one part like this. For the same number another different part can be like this. So if you process in decreasing order, first for this node this would be the largest reachable. For this node this would be the largest reachable. For this node as well this would be the largest reachable here. For this node like this would be the largest reachable. No, first missing number cannot be of order 1 in 9. And yeah, like it was a good question, I would say. Like let's say you have 7 numbers. Let's look at 0 to 10. There would be 4 missing numbers in this range. Minimum 4 missing numbers. because if we can from 0 to 10 there are 11 numbers, and if we have only 7 numbers, then there should be at least 4 missing numbers. So like this was one more thing to look out for. So like first what I did was do one DP to find maximum reachable number. You cannot go to any smaller number. And second time, once you have already computed this, because we know that we can go to a smaller number only once, then we can probably try to find, like, just go to one smaller number once and then see what are the other numbers you can get. Or another way is like you can probably also implement Dijkstra here. No, Dijkstra might not work, but yeah. So like the idea is first for each number find the maximum reachable number, assuming you cannot go to any smaller number. Then for each number, look at what all smaller number are reachable from that, and just take max with maximum of the earlier value we have. So I will probably jump onto the code. This is D1 right now. D1 needs more observation there. Like first thing I did was just made all numbers unique. It's not necessary, but helps a bit. Or probably what we can do is like, probably let's, we don't really need this as well. Read the length and let's find all the numbers which are present here. Let's say we have found the present numbers. Now we can run a while loop to find all the missing numbers. We want smallest two missing numbers, right? As long as length is less than 2. If present does not contain current number, now we can create an array C which will contain all the missing numbers. Like if k is less than m, let's find the answer for all the numbers greater than equal to k up to m. And then now we can set m equal to k minus 1. Like I in fact even saw D2 by the way. Now our remaining part is a graph with k plus 1 values. And we can also create a graph smallest missing would be this. and smallest missing 2 would be this. Now we know that from smallest number we can go to second smallest number, and from any number we can go to the smallest number. Like I am creating a graph where I am always going to the larger number. First. Then I can start with dpk in decreasing order. Max reachable. Max reachable from j, if we do nothing, we will be at j. And for all the edges we have from j, take max with whatever the other value we have. Now the another idea was the next thing was like, let's look at all the first missing numbers as well. Or probably like what I essentially for this problem doing this was enough. Like basically now maintain a prefix max here. Like this definitely takes some extra values as well, but this will also keep, like you can always go to all the smaller values you have, right? Like all the first smallest value, like all the smallest value you can go to them anytime. So probably I think the other way would be like, let's look at all the smallest values first. Maximum you can reach from any smallest would be this. Like what I earlier proved was like you have to jump to a smaller number only once, and when you are jumping to a smaller number, you always land up at smallest possible number, missing number from any sequence. So now once if I am going to only larger number, then like I am taking this max, like what is the maximum I can reach if I jump to one of the smaller numbers. And like for every dp value, answer is lower bound of this, because from any number you can always reach to any of the smallest missing number, and you can then go to the maximum reachable value. Once we are done with this, take some of all the dp values from 0 to m, add them to the answer and print it. And this was the idea I had for the Looks like I'm missing something there. Okay, I should go up to k. Looks fine. So this was the idea for D1. Any questions on D1 before we jump on to D2? Okay, I will jump on to D2. The only crucial difference in D1 and D2 was you cannot choose same array more than once. Like right now, like what I was doing was like from any number I can go to smallest and then I can jump to second smallest. Now I cannot do that. So the main ideas remain same. Earlier what I was doing was whenever I was jumping to some smaller number, let's say, then I could use the same array to jump. Like let's probably take it as an example here. This is the first array. Second array allows me to do a jump like this. Third array, let's say, allows us to do a jump like this. The problem here is if I jump to this, like I am, let's say I am here. Earlier what I was doing was I was jumping here, then using the same array to jump here. These are the same number, then using this array to jump here, and then using this array to jump here. Now I cannot do this. When I am jumping to smaller number, I cannot use the same number to jump again. So what I would need is I would need some another array to jump at this element. So that from here, I make a jump using this array here and then follow a route like this. So any smaller number I am jumping should be missing number for at least 2 elements. Or another way to say is like the first jump should appear 2 times. No, like any smaller jump. Going higher can be done only if a smaller element is missing for 2 arrays. For at least 2 arrays. Like you can even here follow this route as well. If you want to follow this route, then what you can do is you can use this array to jump to lower element and then follow a jumping path like this. And essentially like this was the only difference between D1 and D2. This observation was extra required to solve D2 if you know how to solve D1. So like probably let me just pick my code for D1. This was my code for D1. Let's put it in D2 as well. Earlier when I was jumping to the smallest number, the idea is same. Like the same thing, finding two smallest number, k less than equal to this, calculating dp of max reachable as well. Everything so far like this works. The only thing I should do is like I should not jump from smallest to this number back. Let's also create a missing count, like how many times a particular number, smaller number is missing. This has always exist. Is less than 2. From any number to this number, we could not come, or probably like either we can take, earlier I had two arrays here. J to SM was also I am doing, and then SM to SM2 was also I was doing. Now you can either go via this route or via this route. You cannot take both of them together. Or I would say like you can do this only when missing count. Like if this smaller number comes from two different arrays. Then only create these arrays. So that you use some another array to reach at SM and then you go via this route. Or basically if you use this array to, like basically some another array would exist which would bring the numbers here. Or you can in fact even skip that part. If missing count j is greater than equal to 2, then only you add this edge. Like basically if j is missing from two different arrays, then you can go from any number to j and jump like this. The same DP here. And smallest from missing. Next from smallest. You can always do a jump like this. Like you can always reach the smallest missing number by doing the operation first time. And if smallest missing number is missing from at least two numbers, then you can also reach this number and jump on to the highest number you can reach from here. The same idea, everything remains same, and this was the solution for D2. Like the only critical observation different from D1 and D2 was when earlier you were using the same element, you were first jumping. 1 second. From 147. Like for D2, like only critical observation was if you are jumping to any number which is the smallest first, to go to second smallest number, you will have to come to smallest number from some another array. So any number which is smallest missing for at least two array, you can make higher jumps from there, and otherwise you can. So any questions on D1, D2 before we move on to problem E? So any questions on D1, D2, ABC before I jump on to problem E1 and D2? Okay, I will jump on to problem E1. Let's solve easy version first. Turtle gives you M interval L1, R1, L2, R2, LM, and LM. He thinks that a permutation P is interesting if there exists an integer Ki for every interval, such that if we chooses Ai as max of Li to Ki and Bi as minimum of Ki plus 1 to Ri for every interval, then the following does not also holds. Like you take max of all Ai and minimum of all Bi, and this should hold true. Turtle wants you to calculate maximum number of inversions of all the interesting permutations of length n, or tell him that there is no interesting permutation. An inversion of a permutation P is a pair of integers I, j, where I is less than j, but Pi is greater than Pj. And one critical part was like the answer is never impossible for this subtask. And the one good condition for this case was like all the intervals, like there no two intervals intersect with each other, because Ri is always less than Li plus 1. Or probably let's try to see what is this problem statement asking us to do. Like first, let's see like how does a valid permutation looks like. Let's say this is the first interval. These numbers are not part of any interval. This is the second interval. And let's say this is how some interval looks like. For each element, you will have a mid, some k there. Let's say you have filled elements like this. A1 is maximum in this element. Bi is minimum in this element. B1. A2 is maximum in this interval. B2 is minimum in this interval. A3 is maximum in this interval. And B3 is minimum in this interval. And what we want is maximum of AI should be less than minimum of BI. So what it essentially says is choose some prefixes of each interval and suffixes of each interval. And any value in the chosen prefix should be less than, like this is essentially of all chosen prefix. And this is essentially minimum of all chosen suffix. Any questions on the problem statement? Now it asks us to find one array which has a mid, some prefix and suffixes like this, and number of inversions is maximum possible. Like this is how a valid array looks like, and it says on all valid permutation count the number of maximum prefixes and suffixes you can get, maximum inversions you can get. Any questions on problem statement? Now let's first even solve one more easy version of this problem, where like every interval, every number is a part of some interval. So like intervals look like this. Like there is no missing element to begin with. And let's say you choose first three numbers. You choose three numbers here. You choose four numbers in the remaining part. You choose two numbers here. You choose three numbers here. You choose three numbers here. You choose one number here. Like let's say we have three intervals. First interval is of length 7, second interval is of length 5, third interval is of length 4. And you have decided that the cut in the first interval for prefix suffix, first part will contain 3, second part will contain 4. Cut in the second interval means like prefix will contain 2 elements, suffix will contain 3 elements. Cut in the third part means prefix will contain 3 elements, suffix will contain 1 element. Now you can see like total element in prefix is 3 plus 2 plus 1. Sum of prefix length is and sum of which is also, and total we have 16 elements. So you see like prefix will contain only elements from 1 to 8. This should contain elements from 1 to 8 and this should contain elements from 9 to 16. That is the only way you can have like this prefix 8 elements smaller than suffix 8 elements. Any questions here? Like I am solving for the subproblem where every element is a part of some interval. And let's say this is how I have drawn some green cuts. Then I am saying like prefix should contain all the elements from 1 to 8 and suffix should contain all the elements from 9 to 8. And now we can do some greedy here. What we can do is we can fill all the elements from prefix in descending order. 8, 7, 6, 5, 4, 3, 2, 1. Sixteen, 15, 14, 13, 12, 11, 10, 9. Like I would say like if you have fixed the boundaries and if no element, every element is a part of some interval, then like whatever number of inversions this array contain is the maximum you can get. Any questions on this one? Like now if you remove these, change these boundaries, the array can definitely change. But if you have fixed the boundaries, then this array would be the one which will give you the maximum elements. Because you know like all the white elements should be the largest 8 element. And the best way you can do it over here would be by sorting them in descending order. Because here the part is already fixed. These elements will always be more than this set. These elements will always be more than this set. And so on. But you can try to also maximize like number of inversions you get in this part. Number of inversions to get maximum in this part would be to keep this in descending order. Keep this also in descending order. And if you compare these two, the number of ways to get maximum would be to even keep them in descending order. So now this gives us a DP solution. We have processed first F segment and small count is Sm. Prefix length. Let's say we have processed first I segment. Pref length is this. And what is the maximum number of inversions in this part? Like basically what I am doing is, like say first you have drawn a boundary here, 3 element here, 4 element here. Now if I draw a boundary like this where there are 3 elements here, 1 element here, what we by looking at this boundary, we can see like whatever the maximum elements inversions you got here, plus like these elements would be from 1 to 3. Like the smallest element would be here, and you can increase numbers like this. Or probably let me just create one more interval here first. So far here your prefix length is 6. Suffix length is 5. Sum of suffix length. Now you can, based on this, you can very well predict like you will fill 1 and 2 here, then 3 to 5 here, like basically 1 and 2 here, and then 3 to 8 would be filled in the prefix part, and then 9 to 12 would be filled here, and then 13 to 16, 13 to 17 would be filled in this suffix. So now you can count new inversions because of these pairs, because everyone here is larger than them, and for this pair the largest elements would be this. And like this is the DP idea, when like every element is a part of sum of the element. Now we can have some holes as well in between. What I did for these holes like this was to treat them as segments of length 1. And consider either full part goes to prefix or full part goes to suffix. And like this was one more observation required to fully solve E1. So like first I took all the intervals as input and all the elements which were marked there. And for all the missing elements, I just created interval of length 1 there. Sort them in increasing order. Now I have DP. First I have 0 elements and I have taken 0 elements up till so far. Now I am processing in increasing order of the intervals. I have from L to R. Length of this segment would be this. I create next DP. And let's say we have current length. Like the count of elements we have, the prefix we have already processed. Then like the new length would be like, next length would be like all the current elements I have processed so far, and the new elements which I would be appending. So like next DP contains like all the elements I have taken so far can be smaller, or all the elements I have taken so far can be larger. If length is 1, you say like 1 element go to small part, 0 element go to large part. Or you can say like no element goes to small part, only 1 element goes to large part. You can do this. Or if the length is not 1, basically means this is the original segment and there should exist a k in between. So you say j elements go to smaller part and length minus j go to the larger part. To ensure that every part has at least 1 element, you go from j to length minus 1. Once we are done with this, like we just reassign So we don't really need a 2D array instead of 1D array and same complexity. Small length, large length. You will add all the smaller element in the decreasing order. So number of inversions due to that part would be this. You will also add all the larger element in descending order. So number of inversions due to this in the current segment would be this. PVR small count. Like what is the count of elements which went to smaller part up till the previous segment? Let's call it part inversions. Current inversion count start with 0. Current inversion count first. The count you can get by increasing these elements in the descending order. Now all the smaller elements we add to the smaller part would be less than all the segments we have done so far. So this. And all the large elements we had add so far would be less than all the large element we have increases so far. And the new small count would be previous small count plus whatever elements I have added in the smaller length. And whatever the smaller inversion count I got. And this solves the even problem there. And at last, just take maximum of all the DP values you get. Any questions on E1 before we jump on to E2? Like E2 requires one more observation than E1. Yeah. So the problem with E2 is like the segments can now be overlapping. We can have overlapping segments. That's the only difference here. Like for example, one of the segment can be like this. Another segment can be like this. And another segment can be like this. The crucial part was earlier we were able to draw midpoint anywhere. Now like the midpoint should be anywhere in this part only. Basically the part which is common to all the elements. So earlier we were running the for loop from j equal to 0 to len. Now we cannot do that. We will have to look at like how many starting segments are forbidden here and how many ending segments are forbidden here. While if you have a segment like this, the answer is no here. because this, for this element a segment would be somewhere like this, for this segment would be somewhere like this, and for like the green part, like probably let me draw it with the same color. For blue it would be somewhere like this, for yellow it would be somewhere like this, and it does not matter where we draw it for blue. Like for example, if we draw green here, then like maximum in this part should be greater than this part, and we will have a conflict here. Or similarly, if we draw green here, then also these two would be conflicting, and like that's the main idea. So like if you have segments like, so basically what you can do is you can try to find all the continuous segments like this, like so your midpoint should be anywhere between the maximum of the left index and minimum of right index. As long as you are putting a midpoint in between like this, you should be fine. And if it turns out that minimum of this left index is before right, print -1, it's impossible. And like that's the only difference for this problem. Like you will have to be a bit careful on how do you find the smallest. Idea remains same, read all the intervals, mark everything as visited. For all the unvisited, add single interval. Earlier I was going through one interval at a time, right? I cannot do that now. I will have to go via two-pointer approach. Size of A. We need minimum L. We need maximum L. We need minimum R. We need maximum R. And keep going further. As long as current segment intersects with all the ranges which we have processed so far. Now total range we would be processing right now would be max R minus min L, depends same. If length is 1, the process is same, add 0, 1, 1, 0. Otherwise constant, minimum small count would be max L minus min L plus 1. Large minimum count would be max R minus min R plus 1. So the same for loop. This changes. And here like the also condition is if max L is before min L, then the answer is impossible. Is valid first initially true. If is valid, print what are dp we have got, otherwise print -1. And this was RE2. Looks like I messed up something there. Even this equal to should hold, and then if length is greater than 1 and max L is less than min L, this should be the case. Okay, min R, it should be min R and max L. Any questions on any problem or any other question in general? I think I'm mostly done with today's discussion stream. Like I also got a WA on A by the way. Okay, some tips like you can join the Discord server. Like there I have a channel roadmap to read in 2 minutes. Like you can check out the Discord server I have. This channel where like I have advices like what should you do. Like one of them is like you should participate in AdCoder beginner contest. The reason I give is like this is a rated contest and also many times it contains standard tricks. And the next question sometimes people have asked is like what are the some standard problem on topic X? X can be DP, geometry, or probably something else like counting problems, mathematical problem, or anything. What you can do is you can read about the topic in on USAV guide. This guide has multiple sections, basically divided as bronze, silver, gold, platinum. Bronze is approximately D3. Platinum is harder than D1, and easiest is bronze. Silver is around D2. Gold is around D1.5 or something like that, and so on. So you can read some topics here. Like for example, 2 pointers. Some text is given here, and some practice problems is also given. It explains what is 2 pointers. Sometimes there are animations as well and some practice problems here. Or you can also read CSCS book, which is Competitive Programming Handbook book. range queries, static, a lot of starting topics are there. And you can solve CSCS problems at here. There are around 150 problems segregated as topic. So like string algorithms, mathematics, tree algorithms, etc., graphs, tree, etc., everything is there. Then what I did when I was expert or below, what I was when I was targeting 2100 and probably more like this. And like one very helpful advice is, which is given by Omni, is to get better at X, you should do X. And you can replace X with anything there, doesn't really matter. So probably these were like if someone is struggling with B and C in due to problem, like the first thing they should do is try to solve a lot of B and C problem, then start practicing on the harder problem. Like one at a time. Like first tackle B and C. When you are good there, then you go for D and E. Otherwise, you will end up spending a lot of time on D and E, and probably, I mean, like I take oral contest for to solve just a problem. Like everyone takes oral contest. The problem count just differs every time. For you, it's 2 problem. For me, it was 5, 6 problem. When it comes to D1, for me also it's 3 problems for the whole contest. And same order. So like it's good. Like at least you are thinking for the whole contest, trying to get something there. Like when I initially saw the number of aces on E1 and E2, I was thinking of just skipping them and writing hints block for them. Then I thought for some more time, I realized even at that point of time, number of aces on E2 and F were 11, 12 only. I thought probably now I can start. Then I realized like E2 is one more observation away from E1. Like in fact, I really like this contest. Once you solve D1, you are one observation away from D2. When you solve E1, you are one observation away from E2. Had it been the case that just D2 and E2 were there, I might have not came across them. No, most of the time I do not come across idea. Like I will probably upload my screen cards for this contest, where you can just see me typing different ideas and trying out different stuff there. C was definitely like when I realized we have to maximize adjacent element, I was like, this is the only possible code there. I coded the solution there and then I spent 5 minutes trying to see like, can there be something different over there? And then I just went ahead and submit. I got a C, I went to D. Had I got W, then I would have went to D. And B, when probably I looked at like I have seen similar problems, some similar problems many times. So for B, like I knew like median is the only reason why this problem exists. So I tried making separate cases for odd and even, and then it turned out that median was always the solution there. So I removed those 2 if and made them 1 if. So any more questions before I call it a day today? Look, like the ideas are not sudden. Like you probably analyze problem, you look at some example, try to solve one after the other, and try to come up one observation after the other. You see, like when I was explaining even, I first took the case when every element was part of some sequence. The only reason I did that was because I found it easier, and then I struggled for quite a long time to see like when there were some elements not part of any sequence. Then I realized, oh, probably I can keep the complete segment to some prefix or suffix, and then bingo, I had a solution. No, like understanding questions fast is probably something you will get with some time. Like for example, like in A, I did a bit of hurry. I read the problem wrong. I got a WM. So that happens. And probably like what does the problem statement ask is the first thing we need. So like when you try to solve more problems, you will come across jargon. And like when I was newbie, how many problems did I solve? Like you can probably look at my contest graph here. When I started, I was solving 1 and 2. Like probably, in fact, I was never a newbie, to be honest. Like I would say the only reason is like my first contest. You see, I started in July 2028, 2018 over there, and like you might want to look at my course of graph there. Like the first contest I participated was in October 2017. So by the time I started on Codeforces, like I have solved a lot of contests on Coursera by now. Like July 2018 should be somewhere here. So like I was definitely a newbie on Coursera, and this was the old rating graph. Yeah, like I did give ICPC back when I was in college. Like probably someday I will create a blog on ICPC as well, like some generic advices. For now, like ICPC is due. Like I just want to say, like for ICPC, like the teamwork is really important there. Yeah, like this is my ICPC history. First time I gave in 2019, I went to Amritapuri regional. Second time I went to Amritapuri and Kanpur regional. Third time also, like I was until regional only, and then there was another team from our college which went to the world finals. And then they had some last minute issues, and one of the guy in that team could not go there. So they asked me to join their team. Like I was highest rated in college, but like the teamwork is really important in ICPC, and that was not the case for me. So some juniors like who were really good, like the in the teamwork, ended up beating our team and went to win. So like so I joined their team, and then we were at the highest rank in the Asia Pacific region on the world finals there. Asia West region essentially means the best team from India, Bangladesh, Pakistan, and few more teams around. I don't think a team from Iran was there. Probably Iran may have some visa issues with the world finals was in Bangladesh. So that's where I was. Like which two topics are really important? Like when it comes to topic, like I end up linking. So like Umnik was in Sitpost Moon once, and then he listed out all the topics that he does not know. Like these are quite advanced stuff, and Umnik is legendary grandmaster. Like the main point he wanted to make was stop learning, go to learn Barney. So the main point he wanted to make was like for the initial 1-2 problems, what you essentially need is to get good at thinking skills, logical skills, rather than some topics. While trying to solve some problem, you will come across sometimes GCD, sometimes Max or something. You can figure out those properties at that point of time, and you would be good for the first two problems. Like, can you compile maths topic from CP beginner to advanced? Like, probably someday I will, because at the end of the day, I am a YouTuber. But for now, like, probably I'm not planning to. My weakest topic is DP. Any resources? You can check out the Discord server. Some standard problems on topic X, say DP. You can do this. So I think that's all I have. Like probably I will take 1 or 2 more questions from the chat, and then I will call it a day. And thanks everyone for joining today. I think I have said it like this is the Discord server, or like generally you can find most of the link related to me on this website yt403.com. Like that's the short URL which I have bought. And I think I will end the stream now. So thanks everyone for joining today. And like that's all from my side today.